Good morning, Year 9. Today we're going to have a look at finding the equation of a straight line in the form y equals mx plus b when we're given the gradient and the y-intercept of the line. We're going to find the gradient and y-intercept of a line from its graph and use them to write down the equation of the straight line, and we're going to match equations of straight lines to the graphs of the straight lines. Right, so finding the equation of a straight line from its graph is what I've learnt this one, but as I said, our learning intentions, we sort of got three. Find the equation of a straight line in the form y equals mx plus b given the gradient and the y-intercept of the line. So let's have a look at that first. For our example 1, find the equation of the line in the form y equals mx plus b given m equals 3, b equals 5. So y equals mx plus b. We just need to substitute in the 3 for the m, and we need to substitute in the 5 for the b. So we end up with y equals 3x plus b. Let's have a look at our next one. M equals 2, b equals minus 7, y equals mx plus b. The 2 goes in front of the x, and we're plus minus 7. So when we got a plus minus 7, a plus and a minus is a minus. 2x minus 7 is our answer to that. Our next one, m is a half, b equals 3. Again, y equals mx plus b. Put that half in front of the x, y equals half x. b is plus 3. So our equation, y equals half x plus 3. Our last one, m equals minus 4, b equals 0. Y equals mx plus b. We'll put the minus 4 in. So y equals minus 4x plus 0. Now 0 we don't normally show. Our line is going to end up y equals minus 4x. Okay, so that is our first learning intention, done and dusted. Let's have a look at our next one. Find the gradient and y-intercept of a straight line from its graph and use them to write down the equation of the straight line. Again, let's have a look here. Example 2, let's find the equation of the lines below. So the first thing, finding the equation of this line, the first thing I'm going to do is have a look and see if I can see some points. There's points all over the place that go through the intersection here. I've chosen this one on this axis and this one on this axis because I think it's easy. My rise, the change in y is 2, this is 2, so gradient m equals the vertical rise over the horizontal run. So that is equal to, in this case, 2 on 2 equals 1. So looking at my gradient, I can see that my gradient is going uphill. So it is a positive sign. I've got a positive sign, so my gradient, m equals 1. Now the y-intercept, where is it cutting the y-axis? I just see where it's cutting the y-axis. There it is there. That value is minus 2. So minus 2. So I finish off by putting y equals mx plus b. Now we've got our m, we've got our b. We just do what we did in the previous question. Y equals 1x minus 2, y equals x minus 2. Let's have a look at our next example. Here is my straight line coming down here. I notice straight away it's a negative gradient. I want to find 2 points so they're on intersections. I've got those. My rise is this one, the change in y value. My run is the change in x value. Gradient is vertical rise on horizontal run. 4 on 2. Put that in my calculator if I like, simplifies to 2. Looking at my sign of my gradient this time, I can see it is going down. It has a negative sign. So it's going to be negative. My gradient is negative. It's negative 2. Finally, looking for my y-intercept, where does this cross the y-axis? It crosses the y-axis here. Minus 1. B is minus 1. So now I've got the values of y and b. I just write my equation. Y equals minus 2x minus 1. So that's our next learning intention. And our last learning intention is just to match up equations of straight lines to the graphs of straight lines. I'm not sure if I've got an example for that. I do. So here we need to match the equations to the graph. So I've got 3 lines. Now I can do and I've got 3 equations. So if I'm doing that, I don't really need to absolutely work a lot of stuff out. I can do it by inspection. So when I look down the bottom here, if I look at the lines first, if I look at this one first, this one's got a negative gradient. It's going downhill. The only one with a negative gradient is that one there. And I can check it's got a half the gradient, so it should be going across 2 for every 1 it goes down. Yep, it goes across 2 for 1 down, so we'll give that a tick. And then our y-intercept here, well, we count them, I haven't even got them on there, -3. So that is correct. This one hasn't got any numbers on it, but each grid is one digit. So that was pretty easy. Now look at our next ones, y equals x and y equals x minus 3. So again, if I'm looking at those equations, I notice this one. That's going for the origin because it's when y equals 0, x equals 0. Here's my line going through the origin, so I've matched those up. That leaves my last one, which my last one I can see y equals x, it's got a gradient of 1. It goes through at -3. And both of those go through at -3. There it is, -3. So there we are, we've matched those up as well. And I've written that out here as to what it is. So for today, that is pretty much what you are doing. There are some examples here. Write for the first run, write the equation for the line, it gives you the gradient and the y-intercept. Next one, to actually find the gradient and the y-intercept and the equation of the line. And our last one is matching these equations here to the lines above them. So have a great day.